Okay, so we've got the pigeonhole principle, and it truly is birds. Oh, I wish I could draw birds. Okay, so let's just say I have two birds trying to go to one pigeonhole. So if I have a finite set going to a finite set, and if this is larger than this, there's going to be more than one bird in a hole. That's literally the pigeonhole principle. It'll get a little harder, but the number in the domain, if it's larger than the number in the codomain, that's the idea, that there'll be more than one pigeon in a hole. Okay, so let's go through and look at these. So in a group of 6 people, must there be at least 2 who were born in the same month? So you want to think of the worst case scenario. So think of spreading the 6 people over the 12 months of the year. So no. So in the domain, you have 6 people, right? In the codomain, you've got 12 months. So no. You will not have, you could put people in the months January through June, and then you don't have an overlap. Okay, here we go. So a little bit of a difference. I'm just going to kind of build up in difficulty here. So you've got 10 black socks and 10 white socks in a drawer. And you reach in, you pull something out. They're not folded, so you have to pull out something out. What's the least number of socks you got to pull out in order to make sure that you get a matched pair? So you're looking to go into the hole of black and white, right? So how you've got 10 socks in the domain. So what is the least, and you've got 2 colors in the codomain, right? So what's the least number of socks? So I can say, worst case scenario, if you pick a white and a black, the third one's going to be a white or a black, so you need to pick 3 to make sure that you've got 2 socks of the same color. Okay, so moving up in difficulty here. So here I've got, from this set, I want to pick 5 integers. So if I pick 5 integers, does that mean I have to have one of them that has a sum of 9? So if I pick 5 integers, well, let's look and see which pairs have a sum of 9, right? So 1 and 8, and 3 and 6, oops, and 2 and 7, and 4 and 5, right? So those are 4 pairs. And so if I choose 5 integers, so 1, 2, 3, 4, yes, if I'm going to pick out, so this is picking out the numbers 1, 2, 3, and 4. If I pick out 5 integers, if I choose 5, yes, I will have a pair that adds to 9. Okay, so what if you only pick 4 integers? No, because I could literally pick the worst case scenario, pick the numbers 1, 2, 3, 4, and that would not make a sum of 5. A sum of 9, sorry about that. All right, so here we go with the generalized pigeonhole principle. So this is saying if I got the finite set X and a finite set Y. So if the number in X is bigger than K times the number in Y, then I'll have one of the Y's will have at least K plus 1 of the X's going to it. So, so if you're thinking about N pigeons going to M pigeonholes, then one of the pigeonholes has to have K plus 1 pigeons, where K plus 1 is the ceiling of N over M. So let's bring this to earth with a real problem. So if I've got a group of 85 people, do I have to have at least 4 of them with the same initial? Okay, so N is 85, so that's the number in the domain, right? So that's 85 here. So what number is it times the number in Y? And so what Y is 26. Why do I have Y as 26? Oh, same last initial. Sorry about that. Okay, same last initial. So 26 letters of the alphabet, right? So I know that 85 is bigger than 3 times 26, right? So because 3 times 26 is 78. So K is 3. So what does K plus 1 equal? K plus 1 is 4. So, I want you to know how to use both of these, because we're going to have to incorporate some both of them many times. So if k plus 1 is n over n, then the ceiling, or you could think of it, I'm sorry, as 85 over 26 is 3.26. So that's the ceiling of 4, and that's k plus 1. Okay, so this way, comparing the number from here to get what k is equal to, or using this to get k plus 1. All right, so let's do one more. So here, if I've got 40 people, must there be at least 4 of them who were born in the same month? Okay, so let's use the ceiling. So n over m is 40 divided by 12. So that's 3.33. Whoop, 3.33. So that's 4. So that's k plus 1. Okay, so that must mean, yes, there are at least 4 people born in the same month, right? There's some of the months that have 4 in them. All right, so you could also think of this as 40 is bigger than k times 12 months, right? And what does k have to be? K has to be 3, so k plus 1 is 4. So there are 4 people that have birthdays in the same month, because if I put 3 in each, it's still smaller than the 40.